This is a presentation on the risk-based prioritization of improvement plans for critical infrastructure. The collaboration team for this project involved Michel Julien, the Accountable Executive Officer for the Critical Infrastructure at Agnico Eagle Mines, Pascal Lavoie, the 3 engineers of record on staff, Edward Masengo, Thomas Lapine, Michael James, and then Edwardine Ingebar, as well as myself. Our objectives were to develop a rational, quantifiable, and repeatable method of risk assessment, which would allow us to identify and prioritize areas of improvement for the tailings portfolio. We wanted to determine a comparable risk value for each infrastructure and not only rely on the factor of safety. We also wanted to ensure that our results were easy to communicate and readily understood by those folks who don't have a geotechnical background or may not be as well informed about the tailings management systems. We also wanted to keep in mind throughout the process that the tailings management system is multidimensional. It's not just the dam that we're concerned with. Our basis of work was looking at the well-referenced works of Silva, Lam, and Marr, where they took 48 case studies of different infrastructure types and rated them according to their level of engineering. And that level of engineering assessment included looking at how well it was investigated, designed, and the assessments taken, how well it was constructed, and how it was being operated. And clearly from this graph, where they plotted the factor of safety against the probability of failure for each of the categories, you can see a very wide range of probability of failure for one factor of safety, depending on the level of engineering for the infrastructure. So these are some of the smaller adjustments we made. You can see the differences between Silva's work and ours. We straightened the lines. We used the same data set to do that. We added some interim lines in between, that's pure interpolation between. And we also capped those lines at minimum probabilities of failure for each level. The thing I want you to take notice of is we also added a target line for this exercise in alignment with some of the standards that are out there, including ANCOLD for new dams. It is also the level at which most historic tailings failure have occurred at higher probabilities of failure than 1 in 10,000. Some of the larger changes we made were to do with the number of criteria. So we nearly doubled the number of criteria, and particularly for the operation and monitoring segment, where we added a lot more aspects in regard to the life cycle and changes over that duration for tailings infrastructure. So there's a lot more on governance and management systems, monitoring programs, and actually the performance of the infrastructure as well. The other major thing that we changed was, rather than have each category equally weighted, we actually made each criteria equally weighted, and then the section weight or the category weight becomes a function of the number of criteria within those segments. And you can see as a result that the operation and monitoring category has a bit higher weight than the others all told. But this is a good thing because it is more dependent than on the full life cycle of the infrastructure, and because we have extended durations of these types of infrastructure. With this modified list, this criteria list we included explicit definitions for each level of practice for every single criterion. Here we rate each and every single criteria with a specific level based on the definition, allowing for much more repeatable process and a less variability between results of different readers. Now, going beyond Silva's work, we also introduced the risk classification, as I mentioned. Now, this is just a quick look at a traditional 5x5 chart, which most companies have a version of, and where they classify their tolerance levels between the very high, medium, and low risk. It's a combination of the probability rating against the consequence rating. Now, this chart is a little bit more difficult to use with a complex infrastructure like tailings facilities because we have a lot of extreme and major consequences combined with a very low and low probabilities for failure. And so we have, as a result, a lot of infrastructure that are rated as the low to medium risk. And it is very difficult to differentiate between what to do work on as a priority. So we took this information and we flipped it into a more useful chart where we assign a range of probability of failure to each of the probability ratings of 1 through 5. And you can see the numbers on the grid in the chart are just those pure calculations between probability rating and consequence rating, and the dividing lines between the sections are generally where the transitions fell in the same 5x5 grid. And so you can see how we established the categories of risk on this chart. Now, our general process was fairly straightforward. First of all, with the size of some of these infrastructure, we needed to make sure we were selecting appropriate cross sections to evaluate. In some cases, it was one if the site was fairly homogeneous, but if we had longer infrastructure with variable ground conditions along the way, we would evaluate more than one cross section. With those cross sections, we would select appropriate factors of safety based on all the stability analyses run for each section. We'd evaluate the criteria for those sections to calculate our level of practice score and determine the probability of failure using those new modified relationships. Separate from this evaluation, the consequence ratings were established based on dam breach analyses and other studies. So we would use those results and combine the probability of failure with the consequence to achieve our level of risk. Taking all of these results as a whole, we took them back to the sites to review with the responsible persons and management on site, and giving them an opportunity to provide additional information that may have been missing during our original evaluation process, and allow an update as that was feasible. Now, this is a chart just to show quickly when you have a wide variety of infrastructure, how you can quickly get a good view on where to do work first, because you can now see, rather than having a bunch of low to medium risk infrastructure, you can actually see where some things fall into the high risk. And then also looking at the ones that fall below this target line of 1 in 10,000, we will want to take a look at first. The other thing that you can see on here is that clearly the factor of safety is not necessarily the defining factor to guide whether we do work first. For example, if we look at this point here, it's a factor of safety of 1.4, but the probability of failure is much lower than one right down here, which has a factor of safety of 1.5. So we can use this results to actually start to modify how we would take action on the various infrastructure we are managing. Drilling down a little bit deeper, you can see on here a way that we chart out all of the level of practice scores as per category. And things I want you to take notice on here is that the longer the bar, means that it has a higher level of uncertainty with the results and or lower quality. So we want shorter bars in this graph. And so, for example, if we look at, say, TEX29, which is here quite a long length, we can see the bottom 3 categories, which all have to do with the design stages, the investigation, the testing, the analysis. And that is a much lower quality or higher uncertainties than, say, one over here, TX9. So there's a lot of potential to look into these categories to see what additional work we can do to improve that score. Once we drill down into the results to look for areas of improvement, we actually took actions to revise the results. So the TSF1 is the first 3 bars, and what we did here is we found out that there was some information that had been not available to the reviewers when it was first evaluated. And so the site was able to quickly provide some additional documentation from the construction phases, allowing us to improve the results of that category. And the second bar was additional documentation, again, but now coming from the design engineers that had been used in the past in regards to the investigations of the site and the information of the foundation conditions and a verification then of all the parameters used within the design phases to ensure that we fully understood the conditions of that infrastructure. The second case was a combination of both reviewing additional documentation, which allowed us to shift from the first bar to the second bar. And the third bar, you see there's not much change here, but what is shown on the next set of graphs is that we actually had some buttressing added to the infrastructure based on some data that had come about from new installation of instrumentation and some updates to the analyses there. So we'll see the change on the next slide. The TSF3 is a good example of why this tool should be used in combination with other management system processes, such as the TARP and some of the triggers that are there. This infrastructure originally was evaluated to have quite high quality information, and we were able to give it a fairly good rating. However, changing conditions in the field resulted in some movement on the property, and there was some uncertainties introduced there as to the cause of that. So reevaluation very quickly, they did discover there was some frozen tailings within below the base of one of the upstream raises with some initial investigations. And so with that and using that new data, the stability analyses was adjusted to give us a lower factor of safety, which doesn't show up in this chart here, but you do see the change in the level of practice score because we've now introduced some uncertainties about the construction phase in particular. Okay, now we took some additional information from further investigations and re-updated the design and analysis, leaving some uncertainties there, but in better shape than the second bar. If we move to the last set of charts here, you can see how this looks on the other graphs. So if we look at the blue bars here for now, you can see just by changing the level of practice scores, how that just simply moves us up in the score for the probability of failure. For the second case, you can see again, when you just change the level of practice score, it just moves it straight up. But in the second case where we did some addition of a buttress, it actually changed the factor of safety for that infrastructure, so it moves up and over to the right. For the last case is more interesting because it was actually quite well positioned up here and into the low risk category, but with those changing conditions and reanalysis showed us that our factor safety was in fact 1.3, and a lower level of practice brings us down here. And now the last point, moving it back here again, is once some buttressing is finally in place, which is almost complete right now, it will put us back into this 1.6 a factor of safety and a much better status again on the risk. So just want to close with some conclusions that we did produce and validate a risk-based evaluation tool that was derived and based on the well-recognized works of Silva, Lam, and Mar. We did more explicitly integrate the evaluation of governance management systems and the performance of infrastructures to complement what Silva had done earlier on. With some revisions to some of the criteria, we have also tested this and utilized it against assessing water management infrastructure and heap leach facilities as well. So we know it is applicable for other types of critical infrastructure. We did have, we found that this process we took in terms of reviewing with the sites after we had evaluated everything, and the requirement to utilize documentation for all of the evaluations allowed for a very rapid implementation and a provision of an audit trail for the assessment. Everything is now compiled and readily available for reference in one place. Because we introduced the requirement for needing everything to be based on available documentation and not just personal perspectives, and also having those very specific definitions for each level with each criteria. It helped to remove personal subjectivity, which helps us generate reliable and repeatable results. And because we have these very clear visuals now to show the differentiation of risks, it helps to use this information as a decision-making and prioritization tool so that we can figure out where to spend our time and effort to lower the risk within the portfolio, clearly identifying improvement areas for all of the infrastructure. I'd like to acknowledge the work of Silva Landin-Mar as the basis of our methodology. It's a great work to springboard from. And the partnership with Agnico Eagle Mines has been a really great experience, very much appreciated. They bring a lot of experience and knowledge to the whole project. And just to note that this project is not quite yet done, we are in partnership with Saskatchewan Polytechnique to develop a web-based app for this risk evaluation tool, which is currently underway. So I will close with that and ask if there are any questions and leave you with the thought of whether you have your information in an easily accessible and communicable format for communicating that level of safety associated with your tailings facilities.